Good afternoon. I have a couple of questions before I get started. But I want to start with just thank you very much for the introduction and for the recognition. It's truly an honor for me to be recognized by Michigan Engineering. I can tell you that the school has changed quite a bit since I came here. And when I came to Michigan, 1982 is when I graduated, but of course I started in 1978, and I had one college I applied to, and that was, you might guess. And the reason was I wanted to be an engineer. I wanted to be an electrical engineer, and from what I knew, this was the place to come from where I was, which was in Ohio. And so I was very excited and very thrilled to do that, and and it was a great school then. And I have to tell you, after spending the time I've spent with the students and the faculty, two thoughts occur. It's even better now, and I'm glad I got in then because I'm not so sure I could get in now. It's an amazing university, and I think you're all very fortunate to be part of it. The other thing I learned in my experience is I knew it was a great university here, and when I went looking for jobs, being a U of M grad in this area was awesome. But what I didn't realize is when I went to California and Silicon Valley, how well regarded a EE from Michigan was then and is today. So I'm thrilled to be part of it. I'm thrilled to be able to contribute in whatever way I can to the ongoing success of this great institution. I'm going to talk about my journey a little bit. I have three topics. I'm going to talk about a little bit my story. Second thing, I'm going to talk about some technology trends as I see them from my vantage point. And the last thing, if you can wait for it, is some advice. And I know not to stand between engineers in a parade, so I'll try to keep this brief. How many of you have classes after this? Yeah, so I'm also between you and the weekend. So I came to Michigan knowing I wanted to be an engineer, and I knew I wanted to be an engineer when I was 6 years old. I knew I wanted to be an electrical engineer, and I wanted to run a company. And I didn't know what either of those things were. But my grandfather was, and so I thought that's what I wanted. But I fell in love with electronics growing up, and it led me here. But when I was graduating from Michigan, as is the case now, back then, employers came here, and I think I had 16 employers interview set up when I was here, and then I did some plant trips and visits. But I wanted to pick a place where I thought I could learn a lot, I could grow, and I could have a lot of responsibility early. And I also had a constraint that I needed to stay in the state of Michigan. There was a girl involved, and maybe that geographical constraint was good or bad. I think it turned out okay, but it was a constraint. So the job I took was to work for Procter & Gamble at a paper plant in northern Michigan. How many of you been to Cheboygan? Okay, anybody from Cheboygan? Okay, so I can say what I want about Cheboygan. You know, the joke was it's not the end of the world, but you can see it from there. It's a long way away. But I got a job as a controls engineer to work in a paper plant, but also to be in management. So what was unknown to me at the time is that process control in the paper industry was actually quite advanced back in the 1980s. In fact, continuous process control for industries like paper goes way back. And I'll tell you how different that is than other industries as I tell my story. So I didn't understand how sophisticated it was. I knew it was kind of advanced, but I'll just give you an idea. In 1982, when I went to Cincinnati, which is where P&G is headquartered, you could monitor a paper plant in Long Island from Cincinnati back in the 80s. So for some of you that have no history, what that's like, that's a big deal because the technology was more than suitable to the task and had been around for a long time. So I learned about controls engineering. I also learned that what you really don't like is a lot of change and the ability to run an industry continuously, to run a production line requires tight process control, especially in a place like the industry. But the other thing I learned is I didn't want to be in Cheboygan, Michigan. And so even though I was being successful, the other thing I realized, I didn't want to be at Procter & Gamble. Procter & Gamble was and is a great company. But if you're an electrical engineer making paper in Cheboygan, Michigan, it is not, thank you, and also not going to take you to where I thought I wanted to go, which was more and more management. So I decided I want to get out. Now, companies like P&G are very shrewd. They put their factories in places like Cheboygan, and there's nothing else there. So getting out is not easy. And I know because I sent 100 letters in the summer of 1984. I subscribed to the San Jose Mercury News, and they had a classified section. I sent 100 letters, resumes, cover letters, and I was 100% rejected. Every single letter. And just 2 years ago, or 2.5 years before that, of course, they were all coming to hire me. So the difference between when you're in school and when you're out of school and when you're here and when you're there is pretty significant. So I reached the conclusion that any rational 24-year-old would reach. I have to quit my job and move to California without a new one, even though I had some debt. Now, I would say that in general, I'm a pretty controlled person. Many people know me, think I am hard to read. But in this time, I did something way out of control, which was I up and quit, and I moved without a job. I sold everything I had. I packed up my Camaro and drove to California. And I didn't have a job. But I had friends of friends, and I interviewed with people, and I went and I found a friend of a friend says, come to our company picnic. And so I went to the picnic, and I was talking to some very tired engineers. And they said, who are you? What do you do? And I make diapers. And they said, do you know anything about photography? I was like, yeah, actually, I do. I'm a photographer. I know about, at home, I had a darkroom. And yeah, and they said, perfect, you'll fit right in. And I got a job as a lithography engineer for Cypress Semiconductor, which was a startup. Because I knew about optics, and when T.J. Rogers, who's still the CEO, interviewed me, he looked at my resume, he looked at me, he looked at my resume and says, you're a double E from Michigan? And I said, he goes, what the are you doing making diapers? And I said, that's why I'm here, sir. And so I got a job at Cypress. Cypress was a startup. And so I'd gone from Procter & Gamble, a 100-year-old company, to a brand new company that was pre-IPO. And I'm in the clean room making semiconductors, running steppers, which are $1 million cameras at that time. Today they're $80 million, or $50 million. But then they were $1 million cameras. And I'm working, the only job I could get was Friday, Saturday, Sunday, Monday, 6 a.m. to 6 p.m. in the clean room, right, running these. And I'm the on-duty engineer. So here's what I quickly learned about high-tech semiconductor. Totally out of control. They threw away most of what they made, right? Most of the yield of advanced semiconductor fabs starts at 0 and maybe goes up to 50 or 60%. And there's no closed-loop control on anything. And so I started asking people, I was like, this is insane. You run this batch process that has no control around it. How in the world is this going to work in manufacturing? And I said, in the paper industry, and they just laugh at me. Paper industry. You don't know anything. I was like, no, actually, they've been making paper for a long time, and they don't throw away half of what they make, right? Well, yeah, that's easy. Okay, but you throw away half of what you make, and sometimes more than that. And so a piece of equipment, I'm in the fab, and we're about to buy a piece of equipment from a company called KLA, and it's going to automate part of the process. It's going to do automated measurements. And I'm like, is this going to close the loop? And the KLA guys literally looked at me like, what? Take the input, take the output, feed it back, change it, and control loop, right? You got PID, you guys got this? And they're like, what? I said, wow. So I actually started writing software to take the output and change the variables on the input on the lithography tool, and I started developing my own algorithms to try to create some closed-loop control in a semiconductor fab that hadn't had any. It was like, this is wide open opportunity. The other thing, how many of you heard of Moore's Law? Okay, good. not that it's ending, but you've heard of it. What Moore's law means is they'll never be in control, right? Because as soon as a process starts to get working, they change it, right? The next generation. So the CPKs in this industry are always out of control. So I was a fab engineer, and I'm sitting in my cube, and I can hear the guy across the cube who's in marketing selling a product we don't know how to make yet with design specs that you can't control. And so I was like, I have to go to work for this company, for this KLA company, because what they do is going to be needed forever in this industry. So if I could get a job, so I applied to KLA, and I got turned down. I applied again to KLA, and I got my offer from them, and then I quit my job, and then they retracted my offer. So I got another job for a little while, and then KLA came back to me and said, do you know anybody who might be interested? And I was like, you're kidding me, right? 7 months I've been at this other place. Well, we just need somebody. If you know anybody. I was like, really? So I took the job because I really wanted to work there. I was very passionate about it. And I got a job as an apps engineer inside of KLA. And it was striking to me that this problem was still there. And the notion that there was an opportunity to provide process control in an industry that inherently was always changing struck me as fundamentally a great opportunity. So I worked in marketing. I worked in applications. I was an engineer, and then I was a marketing person. And marketing in a company like this means you're defining the next generation product. You're working with customers and trying to intercept what's going on. Now, the other part of the story is it was mentioned I got my master's because when I went to Cyprus, I realized I don't know enough about how semiconductors are made. So I better go back to school because in undergrad, I'm sure I had exposure, but not enough that it stuck. So I went back and started my MSEE, to learn device physics, to learn more about semiconductor processing. And then during that, I switched because I wanted some business exposure. So I had more understanding of that, and I also understood that this industry, which was growing and evolving, was going to need what KLA had, and I was very passionate about the product and about the industry. So my progression was I moved up, I got sidetracked occasionally where I got put in other roles. It was mentioned I went and did a startup inside the company. But I kept progressing in management, kept thinking I was going to leave and do something else, but I was getting great experience. So my goal when I joined KLA was to work for 5 years and go do a startup. And I talked to some of you at lunch, and I've heard a lot of people want to do a startup. There are plenty of reasons to do startups. There are also reasons to go to companies that are already established. And if you can find one where you get to do entrepreneurial things inside of a big company, it takes away a big part of the challenge that startups have, but it also provides a lot of the upside, which is the opportunity to own things, to develop things with supporting infrastructure. So as I progressed through my career, I still didn't think I'd ever make it to CEO, and it was kind of an accidental thing that happened in terms of the final opportunity, but it was driven by a point in my career where I was taken out of my comfort zone. So we had this great new product. We were doing really well as a company. I was running a marketing group of about 50 people. I felt really good. I made the mistake of going away on vacation during a strategic planning session. Don't do that. And when I came back, I got pulled aside and I said, you know, the guy tells me, we really need somebody to drive Line Monitor. And Line Monitor was taking our engineering tool and putting it into production. And I said, yeah, no, I'm with you. We got to have somebody. In fact, I got Phil working on that right now. No, we need somebody really serious. Well, no, Phil's pretty serious. He's good. He's a good guy. No, we're thinking more like you. I was like, but I have a job. I'm doing it. No, only this. What do you mean only this? Nobody reports to you, no other responsibility. Your only job is to take and come up with a plan for us to get this into production. There's nothing else as a company that we can do that has more leverage than that. And you have nothing else to do. So I was taken way out of my comfort zone because suddenly I was like, I can't ask them, what do you think I should do? They're like, no, that was our assignment to you, actually. What you should do is get us into high volume. And I just thought, what? What kind of assignment is this? my point of telling you this is I'm going to come back and tell you about every now and then you got to get out of your comfort zone because that's when the biggest innovation often happens. And this was brilliant management because they took away the two constraints most people will often cite. I don't have any time. And then I asked what my budget was, and they said, you tell us what you need. And I was like, oh, God. You got time and you got money. We need a plan. And so suddenly I had to back up and I had to, and I'm panicked because my career's actually going pretty well. This was not the disruption I was looking for, right? But what happened was I came up with a plan and I backed way up and I said, what is it we're trying to do here? We're not trying to sell inspection. When I go to a fab manager and tell them I want to spend 5 times as much as they were spending on ours, I better have a compelling story. And the only story I could have that was going to be compelling was about their competitiveness. Now, as it had turned out in my master's program, I had done a paper and taught a class on US competitiveness. And in that, there was a foundation called the Sloan Foundation, still is, that did a book called Made in America back in the late 80s. And this was when Japan was taking over the world, which, by the way, for all of you, that was our world, right? Japan's taken over, the US is out. And they already owned consumer electronics back then, right? Think of the irony there. And they're going to take over everything, and the US can't manufacture. And in semiconductors, if you want to be ahead, you have to learn how to manufacture. And what I realized is what I needed to figure out to sell in this line monitor was sell competitiveness to our customers. Not to sell the tool, but to sell a vision of how they're going to be competitive. And I needed a couple other things. I needed third-party validation. I needed a format to tell my story. And I needed a methodology. I already had the system. So third party, I decided to partner with universities, fund research, and come up, and I needed the math behind the controls theory of why inspection was something you could control. So I funded research out of UC Berkeley to study defectivity and see if you could make it fit a normal or any kind of distribution you could apply control limits to. And some brilliant guys out of Carnegie Mellon and Berkeley came up with a way to extract data that allowed us to put control limits around process control, and I got them to tell the story. And then I got a seminar set up where people could tell their stories about how they were successful. So you're all fab yield engineers for different companies, and you're all coming to my conference, and you're going to tell your story. Why are you going to stand up to your competitors and tell your story about what you've done with yield management? Because you're proud of what you've done, but why will you tell all your competitors? Because your spouse is sick of hearing about it. Right? So you're going to tell somebody that cares, and that's somebody, I'm going to create a community in which people share best practices, right? Which is a lot of what Made in America had done. And I tell you that story because I got put in this position. I didn't know when I was doing the research on competitiveness that it was going to ever play into anything I did until I got this new assignment. I didn't know that when I was in Cheboygan making diapers, making paper, that anything about control theory was ever going to matter. In fact, I thought when I went to Silicon Valley, I was dumping all that experience. And I have a lot of examples like that. You don't know what you're learning while you're learning it. A lot of times, you know it later. So this line monitor assignment propelled my career, though not initially, but during that time, we went from $50 million to $400 million a year in 4 years. So that's a lot. For a company like ours, that was very significant, right? And this was the program that I was on. I'm pretty convinced it wouldn't have happened if I hadn't been made to solely do that, right? To pull that. And this one, by the way, I didn't volunteer for. I was volunteered for, right? And I also don't think if I hadn't had a background where I could have worked with the engineers at Berkeley, that we could have come up with the algorithm. I'll tell you what it was, is defects tend to cluster, and if you remove the clusters, defects follow a Poisson distribution. And if you put control limits on that, you could actually sell that as a methodology, but you have to have an algorithm to remove clusters. It was pretty creative stuff, and when we came up with it, it was one of these aha moments. And the big thing was I wanted a university to be behind it, right? So it had third-party credibility, but it was real. And it made a difference, and customers started adopting as a result. So that didn't get me the CEO job, but it sure didn't hurt my career path. Then I went off to do a startup inside the company. I came back, and eventually I got put in the job. Still today, we are working to try to close the loop in semiconductors because still today, every time somebody gets something under control, somebody changes the process. I used to have customers years ago tell me, we're going to design out your equipment. We're going to make our stuff so in control we don't need you. I'm going to go, that's great, just don't change your process. And they looked at me like, smart ass. So the company grew. The percent of money that people spend on process control in the semiconductor industry is higher than any other industry, right? Because in fact, in some parts of it, it's as high as 50%. Because making this stuff work when you're constantly changing the rules and you have to do it fast is incredibly challenging. So I picked a good place to be, and I had a good background for it in terms of stuff that I couldn't have anticipated. So I want to talk about 3 trends, and then I want to come back to and close on my advice. The trends I see in the semiconductor industry, which I think are more pervasive than that. I think most advances in semiconductor today, in fact, are not because of functionality, they're about power. And I think low power and the work around, all the work that's going on with batteries and low power is much more of a driver than anything else, whether it's IoT or everything else. So if you can somehow align yourself with that. I also know in general, it's because we want low power, but we also want it in the data centers because they're a bigger and bigger consumer of power overall. It was about 5 or 6 years ago when Google's power bill exceeded Intel's, right? And if you think about the data centers, how much they consume. Like power, and I know there's work going on here in batteries, and I know there's work going on in low power. Second one is kind of related but not directly to my world, but it's the world going on autonomous vehicles. And I know Michigan is, I have to give my wife credit, in the driver's seat on this one. There is no driver, I think was the point. It's you know, I live in a part of the world where it's happening all the time, but I think the fundamental research, it's going to continue to explode, and it's not just going to be cars, right? And I know you're working on other areas, but we're seeing it in our customers in terms of their customers, you know, fueling R&D. The last one is cybersecurity. I'm not in a boardroom and meeting where cyber isn't brought up. I did a roundtable recently where I do a roundtable with other CEOs in Silicon Valley once a quarter with about 16 other ones, and I brought up a hack that we had recently had, and everyone in that room had experienced something similar, and the rate keeps going up, right? So and it's a never-ending game. It's a little bit like the Moore's law of semiconductors, because it's a cat and mouse game and you're never done, right? The smarter you get on security, the smarter the bad guys get, and there's a level of state-sponsored work going on, and so anything around that is going to get increasingly important. How many of you have ever heard of honeypots? This is one of my favorite, yeah. So many of you know this. I did not know there was a whole industry out there putting agents inside of IT infrastructures to attract the bad guys, right? And to look like IP so that you can track them, and that's a field. Because if your company's like mine and people come after your IP, you've got to protect it, and you want to be open for collaboration, but you've got to be closed for security. And so this is an ongoing challenge and opportunity. I want to leave you with 3 pieces of advice. The first one, I talked to many of you, as I said, who want to do startups, but startups aren't for everyone. But I do think there's a risk-reward curve that you need to think about, and think about where you want to live on it. There's very high-risk, high-reward opportunities. Startups tend to be in there. But the reason they're high risk is the probability of success is very low. And it's very hard to know in advance who's going to be successful, obviously. And so venture capitalists kind of beat the system because they play a portfolio. And even they, by the way, don't do all that well in general anymore. Right? So they'll play multiple plays. And I have a friend that went to the solar industry a few years ago when that was the hottest thing going. And the VC that invested in him had 12 other solar bets. Right? So they were playing the field, and you can only play your career one game at a time. So you have to think about the expected value of the outcome, especially if your goal is financial. And if your goal is control over what you're doing, I can argue there are plenty of places where you can get that. Companies like mine are dying for people to take control of projects. I told a story at lunch. There's a Michigan grad who I was in a review 2 weeks ago who's running a $150 million program for KLA-Tencor. that we spent $150 million on this product development, and he's the person running it. And he's integrating all the subsystems to launch this product. Startup wouldn't have spent that much money. It's a very cool system. He's going to have success if it's successful, but he didn't have to figure out how to sell it or fund it or raise money or all these other things. But he's got a lot of ownership. So there are plenty of places you can go to have ownership if you can find the right environment. So know your risk tolerance. The other part about that is, of course, it's going to change over time, right? So you have to be aware. When you're early in your career, it is a better time, in some regards, to take bigger chances. To quit your job in Michigan and move to California without one is one thing when you're single. It's another thing when you're not. The second thing is find out, maybe you know it, but find out what really, I hate the word, the passion, but what really you like about technology. You all picked engineering for a reason. And there's aspects of engineering that you probably like and others that are not as interesting to you. For me, it was an intersection of three things. It was this intersection of optics, electronics, and business. And when I found a place that had all three, and it was just something I just happened to love optics. I've just been a photographer, and I'm in a company that makes some very advanced optics, and I find it interesting. I find the people that do them interesting. I find that what can be done with light to be amazing. Right? And I also think algorithms and engineering, the side of building systems, and then I love the business side. So for me, finding those things, whatever they are for you, if you can find an environment that has what you're interested and motivated by, and the people that do them, that will be a good place for you. Some people get seduced by big salary offers or what they think is the glamorous right job to take. And they might take the wrong job in a great company because they think it's the right thing to do. I'd say don't do that. Try to find something that you're going to be interested in. The last one is about the commitment to lifelong education. What I'll tell the grads that we have when we do the new hire or intern orientation is, we didn't really hire you for what you know. We hired you for your capacity to learn. Right? Because what you know is going to be relevant for a while, but what you can learn is what lasts your whole career. So the question is, how do you continue that learning process? What is it that you're going to do? For me, it was a combination of formal and informal learning. And the formal learning I told you about, I went back to Santa Clara. I actually taught for 5 years part-time there, partly because I couldn't go to business school. I thought if I could taught in the engineering management business courses, how they let me do that's a different subject. But if you want to learn something, those of you who teach it know that's how you do it. So for me, that was a way. But the other way I learned seems obvious, but a lot of people don't do this. Is I ask a lot of questions of people around me. And I'll give you an example. When I was at Cypress, I didn't understand how the device worked, and the peers in my area didn't, but I went and found the integration person and befriended him and had him explain it to me because I want to know. Was it going to affect my job right away? I don't know. When I was at KLA, I was an apps engineer, but I found the optics guy and said, do the ray trace diagram. Explain to me how this works. Explain to me, because I'm curious. I want to know. And later, it made a difference because I was able to come up with some ideas because I'd spent the energy to learn. Now, most of your managers won't tell you to do that because it's not directly in your day job. But I can tell you, the more knowledge you have about the broader system, the more impact you can have. The most valued resources we have inside our company, and I suspect in most tech companies, are system engineers, the ones that can span multiple disciplines. So the degree with which you can do that in school is great, but the degree you do it outside of school, once you start working, I think becomes more and more important if you want to take on different levels of responsibility. It doesn't have to be to become the CEO, but if you want to become somebody high level in research, the broader your knowledge is, the better. But it's the commitment to continuous learning that never ends. One of the other things I found about Michigan, one of the great things that I didn't know until later, was the foundational education I had here was very good. And I learned that when I went back for my master's. And even though I dusted off the books and I Schrodinger wave equation, really, again, thought I was done with that. But I was able to work my way through, do more work because I had a strong foundation. And that's something, for me at least, I didn't really appreciate till later. Well, it's been a thrill talking to you all. I'd be happy to take questions, but those are my prepared remarks, if you will.